In this video, I will be showing you how we developed a custom shell for our PCB that you can see here. So the custom shell uses the USB to UART interface. So as if you remember, we have a USB port on our PCB, which is connected to the USB to UART chip, which is then connected to the UART 1 of our microcontroller. So the UART is actually this USB cable here. So it's connected to the USB port of our microcontroller. And from this, we can read data on the serial port. So what you will do is you can let's first remove this hat here, which is an IMU hat, so an inertial measurement unit. So let's say that you simply have your PCB like this. So now let's just open PuTTY, okay, which is a very nice serial terminal. And we can then open a new connection, a new serial connection on a certain port. So in this case, the serial port is going to be on the port here that is defined here. So we have COM port, and you can see the Silicon Labs CP210X. So this is our USB to UART bridge. So we set it as COM10, and the speed is 900,000, 2100, 921,600. So you can just open it, and you should see, normally you should see nothing, okay, because the board is already started. So if you want to see something, you can either reset the board here in the terminal or just reset it manually. So first we will reset the board manually. So just press here. There's a small button here just between the two connectors. I can just press it, and you will see that you have some text that appears here. So the first thing that you can observe is that if you type in the terminal, you will see nothing. But if you press enter, it will actually register a comment. So to see what you are typing, you can go first in settings here. So to change settings, then you can go in the terminal, and for the local echo, just type false on. Now you can actually see what you are typing, which is good. Okay. So the first thing that you can do inside the terminal is typing help. So help like this. That will give you a list of commands. So we can clear the terminal. We can look at monitors. So I'll show you what monitors are. The profilers, you can ignore this. The reset is to reset the board through the terminal. You can type the version to have an idea of the version of the terminal. You can calibrate a sensor. This will not actually calibrate it, but it will put it in calibration mode in the sense that it will start to send data in a way that we can record it to calibrate the sensor. So I will show you later in the IMU video how we use this to calibrate the sensor. And then we have the plot. So this is not very important either. And so I'll show you in the IMU video. And finally the info. So let's first type in maybe info. So info will give us some information. So right now, this is the board we are working with. So it's Orion Rev4. So this is the CAN version. We have a node ID of 4. So if you look at the node ID here, so you can see that one of the dip switches is on, and it is actually the third dip switch. And if you do 2 to the power of 2, it's equal to 4, okay? Because the first dip switch is at index 0, the second one at index 1, and the third one at index 2. So this is the correct ID that we have. It also tells us which source we are using. Right now, I am connected through USB, so the 5 volts come from the USB, and the 3.3 volts comes from the embedded LDO on the PCB. So if I was using this board here, so the external power, and I plugged it in like this, and if I actually power the board through this XT30 connector, it would tell me in the info which that it is using this external power. So right now, it is not using this external power, okay? So this is it for this part now. So now let's clear the terminal and let's plug in the IMU. So if I plug the IMU in any of the hats, you will see what happens. So just plug it in. And you can see here that it has successfully created a thread. So this is a message that has actually been written in the code. Then it requests some configuration. So this is not very important in our case. So let's just do help again. And in help, you can see that we have the monitor function. So let's do monitor, and it will tell us how to use it. So we can do monitor enable, monitor disable, or monitor list. So let's do monitor list to have a list of what we can monitor. Okay, so we can monitor the IMU, accel, gyro, mag, quaternion, and RPI. So now if you want to monitor, for example, the IMU, we just type monitor enable IMU. So here you can see the values of the IMU. So that's pretty cool. Let's just type monitor to have some more information again. So here, if you want to disable it, we can just do monitor disable or monitor disable IMU also. So this only disables the IMU. Now let's do monitor enable or just monitor list again. Okay, now let's do monitor enable mag, monitor enable RPY, and monitor enable IMU. So you see here that we can add multiple monitors and see like the state of our sensor. So you see here the different states. We have some very nice information displayed, which is very useful. Now let's say that I want to disable this monitor here. So just do monitor disable RPY, and that will remove it, and we only are left with these two. Now, if I want to disable everything, I can just type monitor disable. Wait a sec, what is this? Let's just type monitor disable. Okay, and that just disables everything. All right. So, so that's it for this part. Now there are some other functions. So if I type help, there were also the reset. So if I reset the board, you can see that it just resets the PCB. So we just start from the beginning. When you reset the board, it also prints here the different devices that it has found on the board. So here, because we have one IMU, we have three sensors. So one on hat. So we have three sensors on the hat2 on the same I2C bus. We have the magnetometer, the gyroscope, and the accelerometer. Okay. Let's do again a help function. So now we have plot or calibrate, for example. So let's do calibrate. I'll show you more in detail during the IMU calibration video. So calibrate here, I could do calibrate mag, which is what we will be using most of the time. And this will put it in a certain mode here, which we can use in another program to calibrate the sensor. Okay, so now let's do calibrate disable. Okay. So that's it for this part of the video. It's pretty short, but this was just how to use the terminal. And now we will go into the more technical part and how this was coded inside of our STM32 project. Okay, so let's get right into it. So all of this system here for logging the data and showing it on the terminal is done in the system debugging folder here. So the debugging includes multiple classes and multiple files here. And the most important ones are that you will use mostly are the terminal. So the terminal here is a pretty long file, and it defines all of the commands that we can send to the microcontroller and what each command does. So it was handwritten. So you can see, for example, for the version, if we type in version, we check for the argument at index 0, and then we print the data in the terminal. So yeah, so it's quite easy to understand. We just check for the argument, and depending, and you can just like write any code so that it runs here in the terminal. Okay. So you should read through this if you want to add some more functions in the terminal. It's quite straightforward. And the only things that are a bit tricky are the monitors, which I will explain now, and how to define a new monitor that you can actually use in the project. So a monitor is basically just a way to inspect the data that is sent from a sensor, for example. So to do this, we need first to define a monitor ID. So here, these are all of the monitor IDs that I have. So I have for the IMU, the accelerometer, gyroscope, magnetometer, quaternion, Euler angles, and some other stuff. I just give it first a monitor ID here. Okay. When this is done, I can add it in the terminal section. So here in the terminal, I just need to add it. So let's go in monitor. Let's search for monitor. And here you will see that first I will check whether or not, well, this is for the calibrate function, so it's not very useful for us. So let's go into monitor section. So in the monitor section, first I would check if the instance is here or not. So this is just for the list function. And if I type monitor list, then if the thread for the IMU is actually here, then I just print the list of monitors that are available. Now for the enable function of the monitor, if I type monitor enable IMU, then I first check if the thread is available. And if it is, then I can just enable the monitor here. So all of these other things here are less important, but I will still maybe explain it a bit quickly. So first I will check if the monitor is already enabled, and if it is okay, and if it is not enabled, then I go through this section. So first I will check if we have 3 arguments in our comments. In this case, it would be monitor enable IMU, which is equal to 3 arguments. In this case, I can choose also the location of my plot. So for example, let's say I do monitor enable IMU 10, and that will set the monitor at the 10th line, as you can see here. So this is just a way to check for an argument on whether or not we have defined this location argument. If it is not defined, then it will just set the monitors one after the other in the terminal. Okay, so just need to set it here in the enable, and then we can set it also in the disable function. So at the end here we have the disable function, of course. So basically, if you want to add your own monitor, you can just Control F and look for something that I've already wrote and just copy paste it wherever it is used, and you should have something that works. So I won't go into too much detail about this, but I will also show you how it is implemented in the thread. So if you go in the AHRS thread, which is the one for the IMU, you can see that in the main loop here, we have monitors. So these are the monitors. So for the IMU monitor, I check if the monitor is enabled, so with the monitor.enter. And if it is, then I just print the data in the terminal, and then I exit the monitor so that it is constantly updating. So it's very easy. It's a very easy syntax, and this allows us really to send data here in the terminal. Okay. So now the next section that I will talk about is not very crucial to understand, but I will still explain just a bit so that we can have some feeling. So first we'll go through some of these functions. So you can just use them and not understand them if you want. we still go through them. So first we have the console here. So the console is very useful because it's actually the one that handles um, everything from printing data to the terminal, but also passing data from the terminal. So how do we do that? What we do here is we actually use the DMA, which is the direct memory access. Maybe it's not in the console actually. So let's have a look at this. Yeah, so here we have, for example, no, the console is actually just for printing data, right? So we have the console transmit function. Then we can print some data using the transmit. We have the printf, which is used to, well, print data with a certain color. In this case, it's white. We can print in red. We can print in yellow. We can print in green. So this is just a class for printing data. Okay. The debug here just contains all of the objects that we need in order to debug our program. Okay. So where was the DMA stuff? Here the monitor is the things that define the refresh rate as well as the location of our monitor on the terminal. So here we can have, you can see the different functions. So this will save all of the different monitors that we have, their refresh rate and the location, so that it can like update the terminal according to what is inside of that class. Profiler is not very useful in our case, so I won't talk about this part. And the shell here, the shell is used as a way to pass the data from the terminal. So if you look in the shell.h, you will see that the shell is just inheriting from the thread function. So it's just actually a thread. And the shell has access to the console, of course, because the console here is kind of like a global variable, you could say. So, but what this does here is it just passes data from the terminal, and then it will try and create commands according to what we type in. So if you go into shell.cpp, we can see here that in the loop, we will receive data on UART1 through the DMA. So the DMA is very useful because it allows us to really keep the data and not lose anything that we are typing. And it's a direct memory access, which means that it allows us to really send data to the memory without overloading the CPU. So this is a very, very useful feature of STM32. So I recommend using it. Here the receive byte function allows us also to construct commands, and it will also call the comment after we press enter, depending, and it will also so yeah, it will just create a command and call it, and then in the terminal here we can check, we can create these commands here according to what we need. So the shell is just for passing data in summary. The terminal is for defining all of the commands and what they do. The profiler is not very useful in our case. The monitor is used to keep the location, the refresh rates of all of our monitors. The debug is just for defining all of the objects that we need, and the console here is for printing everything to the terminal. All right, so this was a very big and very fast overview of the debug functions of that we wrote from scratch. So I would like to thank Arion Zimmerman for his work on the console here. So I had to modify quite a bit, but most of the code is from Arion, and he did an excellent job at creating this debugging interface for STM32. So I hope this made this made some sense and that it was not too complicated. But what you need to know in the end is that we have some custom terminal that you can use for debugging, and it's very useful and to use in this case. Okay, so see you in another video.